This is a brief discussion on temperature. If you remember from a previous session, temperature is a property that measures the degree of hotness or coldness of a certain object. It tells us how hot or cold a certain substance or an object is. Please remember that temperature and energy are not the same thing. They are definitely related to each other, but and you do need one to calculate the other, but they are not exactly the same things. Temperature just gives us a measure of hotness or coldness of an object. Temperature is measured in units of degree Celsius, Kelvin, and degree Fahrenheit. I would like to point out to the fact that all the three letters are uppercase letters, and the Celsius scale must have a degree, and a Fahrenheit scale must also have the degree sign. The Kelvin scale, however, does not have a degree. Now, here's another thing that we as scientists have to be very, very careful of. If somebody says it's 55 degrees outside, now that is very misleading because 55 degrees is not a temperature measurement. 55 degree instead is an angle measurement because degree tells us angle. But so if you want to report a temperature, you have to be very specific in your units. It's either 55 degrees Fahrenheit or 55 degrees Celsius. Please do note that the units are degree Celsius, degree Fahrenheit, or Kelvin. The two units out of these three, the two units that are metric units are degree Celsius and Kelvin. Both of these are used in the metric system. The degree Fahrenheit, of course, is the English system of temperature measurement. Here are some values. These are more FYI for something for us to be aware of. The boiling point of water, that's the temperature at which water boils at a standard pressure. And freezing point of water is the temperature at which water freezes at a certain pressure. And absolute zero. Absolute zero is a temperature where supposedly all the particles, all the motion comes to a standstill. The kinetic energy is zero. Till recently, this temperature used to be a theoretical value, but research has succeeded in producing such a temperature, of course not under stable conditions. That's not at all a stable scenario to be in, but it has been achieved. So just some values for us to know and compare and be aware of. That water boils at 100 degrees Celsius at 1 atm pressure, or 212 degrees Fahrenheit, or 373 Kelvin, so on and so forth. The 0 Kelvin is considered to be absolute zero, which is equal to minus 273 degrees Celsius. Anyways, what's more important for us is to be able to convert between these three scales of temperature. The formulas are given here, and you do need to memorize these equations. You need to know how to convert between the three scales of temperature. The other interesting thing about the other issue about these conversions is significant figures and or decimal places. Now that can sometimes get complicated. So for the purpose of our class, we will follow the following guideline. When it comes for converting between degree Celsius and Kelvin scale, where the only mathematical operation is either a plus or a minus, we will give the answer in as many decimal places as those in the temperature converted. So we'll use the temperature given, the temperature that is being converted, as the guideline and give the answer in as many decimal places. But when we are converting between degree Celsius and degree Fahrenheit, we will give the answer in as many significant figures as the temperature that is being converted. So please mark these guidelines. These are not rules. No, not at all. These are just a guideline that we will use in our class for the purpose of consistency. Okay, so let's use these formulas to convert 188 degrees Fahrenheit to Celsius and Kelvin scales. Now, do remember that there is no direct relationship between degrees Fahrenheit and Kelvin. You have to go through Celsius anyways. So let's convert degrees Fahrenheit to Celsius. The formula says degrees Celsius equals the temperature in Fahrenheit, which is 188 given, minus 32. The subtraction has to be done first, divided by 1.8, and the order of operation is extremely important in this case. You must subtract first and then divide that by 1.8. When you carry out this conversion, you get 86.66666, it just keeps going, degree Celsius. As we said before, when we are converting between degrees Celsius and Fahrenheit, we will focus on the significant figures. So since our original temperature is given in 3 significant figures, we will report this as 86.7 in 3 significant figures as well. Kelvin temperature can be obtained by adding 273.15 to the degree Celsius. When you add the two, we get 359.85 Kelvin. And as we decided before, this time we'll account for decimal places as the temperature being converted. Since the temperature being converted is in 1 decimal place, we will round this also to 1 decimal place, making it 359.9 Kelvin. Okay, here's another question basically that is asking you to arrange these 3 temperatures in increasing order. First and foremost, please remind yourselves what is increasing order. Increasing order means we start with the lowest and go to the highest. We are going up the stairs from the bottom stair to the highest step. Okay, so how do we solve this? The best way to solve this is to convert all of these or express all of these temperatures in the same unit. And it's up to you which unit you choose. It doesn't matter at all. I chose degrees Celsius. When I converted to convert 301 Kelvin to degrees Celsius, I would need to subtract 273.15 from that, which gives me 27.85 degrees Celsius. And when I'm converting degree Fahrenheit to degrees Celsius, I would once again subtract 32 from this first and then divide by 1.8. That gives me 97.8 degrees Celsius. So now when you compare the 3 degrees Celsius temperatures, you can arrange them in the increasing order. The lowest temperature is 301 Kelvin, followed by 83 degrees Celsius, and the highest temperature is 208 degrees Fahrenheit. So that would be your increasing order of these temperatures.